Transhub device, allowing for that modularity we were talking about earlier. And finally, the Transhub will be powered by a standard rack mount supply of -48V DC, or with options of 120 or 240V AC. And I'm going to hand it off to Mr. Hartzell, the software engineer.
Thank you, Mr. Day. And once again, I'm Jeremy Hartzell, software engineer for Synonym Systems. I'll be discussing with you today our scheme for management during this process. We have designated the project into 6 logical phases: research, design, prototype, testing, management, and documentation. Beginning in research, our hardware research will be primarily concerned with the selection of the microprocessor, FPGA, and power supply components necessary. During software, we'll be primarily concerned with leveraging the FPGA as well as any other necessary. In communications, we'll be concerned with the protocols, each individual protocol involved. Under design, we will be leveraging our research to come up with our initial schematics and PCB layouts for our hardware. Our software will be coming up with our flowcharts, UI mockup, pseudocode, and such. Communication schemes will be designing our management information base for administration of the SNMP protocol of the device, as well as a translation scheme from the SNMP to TL1. Moving on to the prototype phase, we'll begin implementation of our PCBs, hardware schematics, as well as refinement on those based on findings. We will implement our software onto this hardware and refine it based on those, and we will build our communications on top of our software and hardware and refine it based on that. Move on to our testing phase. We will take our findings from the previous sections and plan a thorough test plan for hardware, software, communication sections, as well as a total system integration. Move on to our management phase, where we locate our procurement, where we will be obtaining all of the necessary resources for our project, followed by team management for scheduled internal meetings or informal meetings, that kind. Presentations for our official meetings with our advisors, sponsors, or other stakeholders. And a wrap-up category for general post-project tasks. And finally, our documentation phase will be primarily concerned with our capstone design document, our user's manual, and any other final project documentation. Move on. Extracting the primary milestones from our work plan, we've come up with this timeline. Our microprocessor and FPGA will be chosen around September 3rd of 2010, followed by, we will have it obtained shortly thereafter, and have simple operations on it as soon as possible around the 19th of September. Followed by our RS-232 in and out, FPG UARTs in and out, as well as our Ethernet in and out on October 2nd. Moving on we have our communication stacks, our TL1 stack on October 17th, and our SNMP stack at the end of October. We will have our TC104 bus operational by November 4th of 2010, and have our core functionality tested by November 10th. We know that these milestones will set us up for success and keep us on track, on schedule, and if not early, for our deliverables. And our deliverables are the physical documents we'll be handing to our sponsors and advisors, and other stakeholders. But we have set up this schedule for them. We have our initial software flowchart on the 10th of September, followed by our UI mockup, our alpha hardware schematic on the 22nd, and our preliminary PCB layout shortly thereafter. We'll have our preliminary code build based on that on October 1st of the year, and our beta hardware schematic as of the 9th of October, and our alpha PCB layout shortly thereafter. Moving on, we will develop our preliminary test plan based on the revisions the previous documents, followed by our beta PCB layout, our alpha test plan, and our beta test plan on the 12th. We have our beta code development will be deployed on the 15th of November, and our user's manual will be finalized as of the 20th of November. And our final project, our final prototype and final project documentation will be provided and presented on the 7th of December 2010. I'd like to hand it over to Mr. Berglund.
All right, thank you, Jeremy. I'd like to take you through some of the other evaluations that our company has given to this project. To start with, I'd like to go over a rough order of magnitude estimation of our expenses on this project. Assuming that our labor is worth $30 an hour and that each team member will work an average of 25 hours a week, we estimate $45,000 for our total labor expenses. Next, our design software, which includes hardware tools like Multisim and Ultiboard, and software tools like Multisim and Ultiboard for hardware and integrated development for development environments for software, should total $1,500. Next, our actual hardware expenses, such as PCB, integrated circuits, the microcontroller, and field programmable gate array included, should total to around $1,000. And we estimate that the test equipment required for an electronics project like this, like multimeters and oscilloscopes, will come out to be $2,500 for a total of $50,000. Next, I'd like to talk about the qualifications that make our team uniquely suited to this project. To begin with, Jeremy, our software expert, has years of experience in a variety of different programming languages. Of particular use to this project are his experience in C and VHDL, which will be useful for our microcontroller and field programmable gate array. Next, Ryan, our hardware specialist, has had several previous hardware projects, and what he brings forward from this that's particularly of use are his skills at schematic design and PCB layout, which we'll require for this project. I'm Michael Berglund, our communications specialist. I've had web projects and coding experience in the past. What's particularly important that I bring to this project is the ability to do traffic obtaining and analysis. Finally, Philip Daw, our systems engineer and project manager, has both experience in hardware and software, and his Navy experience will allow him to bring leadership ability to his project management role. Finally, I'd like to go over the technical merit. This is an internal company evaluation of whether this project really requires a skilled engineering team to pull off. We believe this presentation has already demonstrated a well-described and understood technical challenge. We believe the plan that we've outlined will result in the need for several different hardware design, fabrication, and tests, like the overall PCB, the power supply, any extension bus work. We believe that the project merits software design, development, and test in the form of the management information base, the microprocessor control, and the field programmable gate array work. All of these will have to be integrated into a complete and total system as we head towards fabricating a prototype, which we will then test for the benefit of finally delivering and testing on a site for Network USA. At this time, we'd like to open up the floor to questions.